Okay, so for this first problem, we are doing a one-tail test, and we're trying to find the p-value, okay? The critical region or the critical value region. So what we have to do is we need to look up on our, for a one-tail test, and we want z is equal to 1.70. This is going to be a right tail test. So what we're looking for is the critical area, this area right here on the right side, since z is a positive 1.70. So what we have to do is we have to look up our critical value. If you look at your table at 1.70, you can see the area of less than 1.70 is 0.9554. So we want the area to the right because this is a right tail test. So here's 1.70, and the reason we know it's a right tail test is because it's positive. If it was negative, it would be on the left side. So this area here is 0.9554. So if we want the value over here, we do 1 minus 0.9554, and that is how we get 0.0446. Now, since alpha is 0.10, what you have to remember here is if the p-value is less than the p-value is 0.0116. 0.0116 is less than 0.02. So since the p-value is less than alpha, we have to reject. And then the p-value here, sorry, I was looking at the wrong one, is less than alpha, we have to reject. For B, the one-tail test, negative 2.95, if you look up negative 2.95, first of all, this is going to be a left tail test. So we're looking for the area left of this. So that's exactly what we get on the chart. So if we look at the area to the left of this, negative 2.95, we get 0.0016. 0.0016 is your p-value. Since your p-value is less than alpha, again, we will reject the null. For C, we have a two-tail test. So what we have to do here is we have to get the value of 2.20. Let's look up that first, and then we'll work from there. If we do negative 2.20, we get 0.0139. So 0.0139. Let's draw this out real quick. Okay, so 0.0139. First of all, since it's the two-tail test, we have to do negative 2.2 and positive 2.2. Well, since we know that this area here is 0.0139, that means this area here is also 0.0139. So we have two tails, so we can multiply that by 2, and that is how we get 0.0278. And 0.0278 is smaller than 0.10, and that is why we reject. Okay, moving on down. For the last one, we have to find the two-tail test, negative 1.02. So if you look up negative 1.02, you will see it's 0.1539. So what we have to do is think about it like this for a second. It's a two-tail test, and we have negative 1.02. We know that the value of negative 1.02 or less than that would be 0.1539. which means that it will be the same thing for positive 1.02.1539. So if you do 0.1539 twice to add the tails together, you get 0.3078. Since 0.3078, the p-value is greater than alpha here, we will not reject. Okay, for question number 2, this is a hypothesis test. And since the alternate hypothesis is greater than, if it's greater than, then we know that it's going to be a right tail test. That's very important. So what we have to do is we need to calculate the z-test statistic. And the way you calculate the z-test statistic is you do the mean, which is 50, minus mu, which is 47. You can look in the example to get the formula. Divided by the standard deviation, which is 27, divided by the square root of n, which is 49. And if you put all of that in your calculator, you will get negative 1.81. Okay, so what this is our test statistic. All right, negative 1.81 is our test statistic. Now, our critical value here for test statistic is 1.3. Sorry, I'm looking at the wrong one. Okay, so on this one, okay, so I made a mistake on that one. I was looking at the wrong problem. This is question 2. It was, our z value was 50 minus 47 over 13 divided by the square root of n, which was 35. So you end up getting, for your test statistic, you end up getting 1.37, I believe. And your critical z-score, okay, first of all, it's a right tail test because this greater than means right tail. If it's less than, it's left tail. If it's not equal to, it's two tail. So we know that our critical score, if we look at our table, our z-score for a, what was our, alpha is 0.01. If we look at our z-score for alpha is 0.01, we would get 2.33. So our critical value is 2.33. So this is our critical area. If it's in this critical area, we will reject it. If it's not in this critical area, we will fail to reject it. Okay, so our test statistic is going to be somewhere over in here. It's not going to be in the critical area. So what that means is the critical z-score we looked up on the table is 2.33. Because our test statistic is less than this critical value, we can't reject it. Only if it's in this area, if it's greater than 2.33, can we reject it. Now, how do you find the p-value? You go to your table and you look up 2.33. And if you look up 2.33 in your table, I believe it's 0.9147. But we want, our p-value is this side. So if we do 1 minus 0.9147, you will see that our p-value would be 0.0853. Because when you look it up, it's going to give you the area to the left of your test statistic. And we want it to the right. So you have to look it up at you have to look up 1.37. I'm not sure if I said that right. And that's going to give you to the area of the left of it. We want to know the area to the right of it. Okay, this is going to be a two-tail test. And we know what it's not equal to. That's how we know it's a two-tail test. So we need to do the z-test statistic first of all. So the mean is 105 minus the Null is 112 over 27 divided by the square root of 49. So you end up getting negative 1.81 as your test statistic. Now, this is a two-tailed test. So if you look up your critical z-score, you have to do alpha divided by 2, which is 0.05. So your critical values are negative 1.65 and positive 1.65. So if our test statistic falls within these areas, it's reject. But as you can see, if we look at negative 1.81, it would be in this area over here. So since our test statistic doesn't fall in between here, if it fell in between here, we wouldn't reject it. But since it doesn't fall in between here, if it fell in between here, we would not reject it. But if it falls in this area over here, we have to reject it. And then the p-value, if you look up negative 1.81 in your table, you're going to get, I believe it is 0.0351. You look up negative 1.81, but then you have to do this tail over here. So 0.0351 times 2 would be 0.07. Okay, for question number 4, we had to set this up ourselves. Remember, the equal to has to be at the top. So 32 or less, a university advertises that its average class size is 32 or less. Okay, so 32 or less is less than or equal to 30. Now the z-test statistic. Okay, we know greater than is a right-tailed test. Our test statistic would be 34.4 is the average minus our hypothesis, which was 32, over 9 divided by the square root of 40. Standard deviation is 9, 40 is in. So once you do that, your test statistic is 1.69. Now your critical z-score for alpha being 0.01 is 1.69. And this is a right-tail test. Sorry, 2.33. Put the wrong number there. We want the critical value here. So our test statistic is not in the critical value, so we cannot reject it. Because our test statistic is less than the critical value, we do not reject the null. The p-value, if you look the p-value up, if you look up 1.69 in your table, you're going to get 0.9545, but the p-value is, we want this side. So we have everything to the left of 1.69, so we have to, when it's a right tail, you have to do 1 minus, and you end up getting 0.045. For number 5, to do your z-value, you do 1.85 minus 1.70 over 0.4 divided by the square root of 60. So your test statistic is 2.90. Your critical value, since it's a two-tailed test, for 0.05 divided by 2 is 0.025. So your critical values are negative 1.96 and positive 1.96. And our test statistic is 2.90. Okay, so it's in the rejection area. So it doesn't fall within here. We have to reject it, okay, because it's in the rejection area. The p-value, if you look up negative 1.96 for your p-value, if you look that up, you have to times that by 2. So whatever you get there, you have to times that by 2. So your p-value for this test, let's see if we have time, is 0.0019 times that by 2, and that's how you get 0.004. It rounds up.